Happy Friday. Yesterday we did all the different angle reasons that we have, and we completed all these different justifications, paying attention to some special words as you go through. Supplementary, 180, definition of supplementary, 90, complementary, definition of complementary. So there's a lot of keywords, a lot of special words in the statements that we can use as justification for our reasons. Okay, so if you pay attention, things work pretty close. You can see at the bottom of the page here we have the reasons bank. These are all justifiable reasons that we can use when we're doing our angle proofs. And again, got to know all of these things, ladies and gentlemen. You've got a test on Tuesday, I think. That test on Tuesday is matching. Lots of matching. A couple of proofs, but mostly matching, okay? So got to know all those different things. So let's try some of these proofs. And again, our job is to kind of go through and figure out how to justify all these different things. So we want to complete the proofs by filling in the missing, I think all of these are just missing reasons that I did, yeah. So right off the bat, PQR is a right angle. How do we know that? It's given. Hey, please, ladies and gentlemen, do not be that person who writes nothing down on the proofs. This is a free point, isn't it? Yes, it is, okay? So please make sure that you can at least go through and write the given down, okay? All right, so I'm going to mark my picture because it's really important that you do that. There we go. PQR is a right angle. Ladies and gentlemen, what does it mean if I have a right angle? What do we know? It's equal to 90 degrees. Look at that. That's the second step. Good job. How did you know that? Because definition of right angle. The definition of a right angle. That's why the definition of the right angle, again, if you flip back a page, is that if it's a right angle, then it's 90 degrees. That's the definition, okay? And definitions go forwards and backwards. All right. Okay, so now when we look at this picture, how could they say that the measure of PQS plus the measure of SQR equals the measure of the whole angle? Angle addition postulate. Piece plus piece equals whole. Angle addition. That was an easy one. Angle addition postulate. Piece plus piece equals the whole thing. And this is where having the picture and looking at the picture helps us figure out the reason. Angle addition postulate. Okay. So now I have little piece plus little piece equals the whole angle. Okay, so let's look. Now, when I look at the next thing here, I'm noticing what's staying the same and what's changing. So when I look, I see, hey, measure of PQS, that stayed the same. The measure of angle SQR stayed the same. Oh, here's the change right here. Measure of PQR became 90. Why? Substitution right here. They traded out the measure of angle PQR for 90 degrees. This is substitution. Or transitive. I think it's substitution, though. Transitive would work as well, but either or on those. I think it's substitution. We're just substituting something out and putting in a number, putting in a value. So I think that's substitution. But okay. Now, if I have an angle plus an angle equals 90 degrees, 90 degrees means they're complementary. How do we know that they're complementary? Definition of complementary. If things add to be 90 degrees, then they are complementary. Do we have things that are adding to be 90 degrees? Then they're complementary. Okay. So the key to the reasons is within each statement. Okay. So use those words. You're probably going to have to use those words. Okay. All right. Let's look at number 2. All right. We have, first of all, angle 2 is congruent to angle 3. So step 1 here, what's our reason? Given. All right. Now, I want to mark that picture up. Again, angle 2 is congruent to angle 3. So these two angles are the same. Let's see, angle 1 and angle 2 form a linear pair. Oh, look, it's right there. Can I also write given in for that? Okay, great. You just earned 2 points. All right. Good job. All right. Ladies and gentlemen, what allows us to go from congruent angles to equal measures? Definition of congruent. Very good. Definition of congruence. We're trading out equals and congruence. Congruent angles, equal measures. Okay? Let's look. On the second given statement here, it says angle 1 and angle 2 form a linear pair. That is absolutely true. They told us that. And do they look like a linear pair? Yeah. And so if they are a linear pair, angle 1 and angle 2 are supplementary. If they're a linear pair, then they are supplementary. That's a true statement, right? Do they absolutely look like they to be a supplementary? Yeah, okay. What is that reason? How do we know that? If they're a linear pair, then they're supplementary.
Excuse the interruption. 7th grade students whose last name begins A through C, please go to the Wellness Center. Thank you.
The welding center, yeah. Okay. The linear pair, yes, the linear pair, and I'm going to put supplement theorem, linear pair, sup theorem. Again, they've got a linear pair and they're supplementary. That is a whole theorem, the linear pair supplement theorem. And again, if you look back to the reference sheet, here it is, the linear pair supplement theorem. If two angles form a linear pair, then they are supplementary. So it's all right here for your reference, okay? All right, so now we know they're supplementary. Okay, if we know they're supplementary, what else do we know? They equal 180, and that's the next thing. The measure of angle 1 plus the measure of angle 2 equal 180. Well, how do we know that they equal 180 degrees? No, what does supplement? Yeah, it's what supplementary means. The definition of supplementary is if they're supplementary, then they add to be 180. And that's what this is saying. They add to be 180, right? Definition of supplementary. Again, if there's a vocabulary word, you're probably going to use it. Okay? All right. Interesting. Look at number 5 and 6 here. Step 5 and 6. Look at what stayed the same and what changed. Yeah, angle 2 swapped out for angle 3. That's what changed. Why? Because they were equal to each other. Right here, they say they're equal. And how do we take one thing out and put one thing in? Substitution. Substitution. All right. So again, seeing how they're trading things out. They said they were equal, so I'm going to take one thing out and put another thing in. Great. And now, because angle 1 and angle 3 add to be 180, I can say that they are supplementary. How come I can say that they're supplementary? Definition of supplementary. Supplementary. Definition of supplementary. Sup. Again, if they add to be 180, then they are supplementary. Definition of supplementary. Okay. Questions on this one? Do you think you're starting to see how you piece together these little reasons a little bit? Okay. All right. Number 3 here. Angle 1 and angle 2 form a right angle. That is the first thing here, so that is given. Do I have another given I need to write somewhere? Step 3 also is a given. It's a good place to start, ladies and gentlemen. Just fill in the givens, yeah? Okay. I do want to mark my picture. Angle 1 and angle 2 form a right angle. And therefore, I can say that angle 1 and angle 2 are complementary. Let me look back at my reference sheet, because I don't know. Let's see. Right angles and complementary. If you turn the page back, do you see something where it says of right angles and complementary? Oh, there it is, the complement theorem. If they form a right angle, then they're complementary. Hey, okay. All right. If they form a right angle, then they're complementary. That is the complement theorem. Complement theorem. We could also just write if right angles, then complementary, which is a little more specific. It's a little better, but you will have to recognize the complement theorem. So if right angles, then complementary. Okay. Now, if they're complementary, let's see. Oh, we also know, just kidding, we also know that the measure of angle 1 plus the measure of angle 3, these two angles, I'm going to put little stars in them, these two starred angles add to be 90 degrees. That was also given to us. Let's see, so 1 and 3 equal 90 degrees. And how come I can say then that 1 and 3 are complementary? Definition of complementary. Definition of complementary. Yeah, if two things add to be 90 degrees, then they are complementary. So that makes sense. Definition of complementary. Okay, now this one's really interesting. These two statements I'm going to highlight because they're kind of new to us. These are new ones. If you look, we have a statement that says angle 1 and angle 2 are complementary, and angle 1 and angle 3 are complementary. Well, they are, but we have a special theorem that says, let's turn the page. Ooh, it's raining hard. I love the rain. I decided, because I've lived in the desert pretty much my whole life, that when I got here, I always loved coming to Michigan because I just felt so nice here. It just feels so good to be here on your skin. Like, it just feels good. And I decided that when we finally said, we're just moving to Michigan, I decided it was because I'm a Pisces, and so I was like, I needed to be near water. And so, in the desert, I wasn't comfortable. It makes total sense to me. Okay, I'm sorry, I digress. Here, we have two statements, very important statements. Angle 1 and angle 2 are complementary. Angle 1 and angle 3 are complementary. If two angles are complementary to the same angle, then they are congruent. If two angles are complementary to the same angle, and when we look at this, we have two angles, angle 2 and angle 3, that are complementary to the same angle. Then, angle 2 and angle 3 must be congruent, and that's what that theorem says. So these two statements are very important, and these are the two statements that this congruent complements theorem talks about. If two angles are complementary to the same angle, then they are congruent. All right? And so this reason is the congruent complements. I cannot spell in the morning. Theorem. Oh, that is right. Okay. Congruent complements theorem. If two angles are complementary to the same angle, they're both complementary to angle 1, then those angles must be congruent. Okay, so that's a new one, kind of an interesting one. So let's see if there's any more here. Oh my gosh, that's the end of the packet? Yeah. Holy moly. All right. How are you feeling about these? The review is on paper. And the test is also on paper. Okay, let's see. Number 4 here. Let's see, BE bisects angle ABD, right there, that is given. Where else do we have a given? Number 3, yes, BD bisects EBC, so that is also given. We have 2 nice little givens there to fill in. Now I want to mark my picture. It says BE, ray BE bisects. What does that mean if it bisects? Right through the middle. It bisects angle ABD. It bisects it. Oh, so how come we can say that angle ABE is congruent to EBD? Why are these 2 angles congruent? It bisects. Yeah, definition of bisect. Definition of, I can get real specific, angle bisector. Definition of angle bisector. Definition of bisect I think is fine as well, but we're talking about angles, so we could throw that in, the word in as well. Okay. All right. Bisect means we get 2 congruent parts. Great. All right, let's look at the next one. BD, ray BD, bisects angle EBC. If ray BD is bisecting, what do we know? It cuts the angle in half. So we get EBD, this angle, EBD congruent to DBC here. All right, why do we know that those 2 angles are congruent? Definition of bisect. Definition of angle bisector. Or definition of bisector. Fine. All right. Now we have another congruent statement. ABE is congruent. Where else do you see angle ABE? Step 2, right here, angle ABE is congruent to angle DBC. DBC, where else do you see angle DBC? Step 4. Do we have a chain? Do we have a linking path to get there? We do. ABE goes to, is the same as EBD, and then EBD. So we could go from here to EBD and then to DBC. So there's our one hopping chain. All right. What is that called when we have a chain of things linking? Transitive. Very good. The transitive property. All right. That's kind of a fun one. Do my colors help? I think they help a lot. Yeah, I think that's real good. Okay, let's just do this last one here. And I think that'll be fine, number 5, and we'll call it good. All right, right off the bat, I have RSU is congruent to VST, number 1, because it's given. Hey, very good. Let me mark my picture. RSU, this little angle right here, and it's congruent to angle VST, this little guy over here. Those 2 angles are congruent. Let's see, what's the next step? Very good. Yes, how did you know that? Okay, good. Good. What's changing here? The equal sign. We're going from congruence to equal measures, okay? We're going from congruence to equal measures. That is the definition of congruence. We're allowed to switch between the 2, okay? All right, now let's look. This is an interesting statement. Let's see, it says the measure of angle RSU, so I'm going to put a little star in that angle, plus the measure of USV, so that is that little angle, equals RSV. That is both of them together. What allows us to make that statement, that little star plus little star equals? Angle addition, postulate. Very good. Angle addition postulate. Okay. And then we have another statement kind of similar. We have the measure of angle VST. So that's over here. I'm going to give that a little smiley face.
7th grade
So angle VST with a little smiley face, and then the measure of angle USV, here's another, there it is, USV with a little smiley face equals UST. Again, those two angles together, what is that? What allows us to say smiley plus smiley equals the bigger thing? Angle addition postulate again. Angle addition postulate. Okay. Let's look at number 5. Is it the same? Let's compare. What is it exactly the same as? Let's see. RSU, the measure of RSU that's the same as step 3. And then USV is the same as step 3. Those are the same. And then it looks like we have the measure of angle RSV became the measure of UST. It is substitution. I'm just trying to see where why. The 4, wait, okay, so where? I'm not seeing it, guys.
The fourth RS.
Wait, Bella, you tell me.
The first one in number 4 and the first one in number 5 equal each other. So you're subbing in RSU for VST.
RSU. RSU is equal to VSG. RSU. I don't know why I'm like not seeing this.
Like where VST is, instead of doing VST, like.
Oh. So they're switching. Oh, interesting. Okay. Thank you. All right, now I see it. Thank you. Oh my gosh. I haven't done these, so this is all new to me too. Here we go. Looking at step 4 here. Okay, that makes more sense. I was looking at the wrong step. Thank you. Okay, here we go, because I was like, I'm not seeing it, but you're right. Okay, I was looking at the wrong thing. Okay, here we have UST is the same, USV is the same, and here is the thing we're replacing. See how proofs are not easy. Okay, this is the thing that makes sense. Because right here, we know that VST is the same as RSU. So this is the step that we're replacing with substitution. I was trying to replace the wrong thing. TUTION. Thank you. Good job. That's what happens with proofs. You're just like, what? All right. So I was trying to replace the wrong thing, which makes it really hard. I'm like, wait a minute, how does that make sense? Okay. Okay, so now we did a little substitution. And now, where else do we see, why are we saying that the measure of angle RSV is equal to the measure of UST? Again, where do you see those? I see RSV right here, and then I see UST also right here. How do we get there? How do we claim that this is equal to this? These are both the same, yeah. RSU, and that's what I was saying before. These two statements, RSU, the measure of RSU plus the measure of USV, they're matching. So we have a chain. We're going RSV to the highlight and the highlight to the UST. So what property goes transitive? Yes. There's that chain, ladies and gentlemen. Again, these things can be hard to find sometimes, but there's that chain, the transitive chain. Okay, now what's going to let us go from equals to congruence? Definition of congruence, very good. All right. Do you have questions for me? All right, you ready to give it a try? Yeah? Do you get your review packet, you mean? Do you want your review packet today? Yes? Okay.